Hello, everyone. Thank you very much for joining us today. My name is Tristan Morrison. I'm here with my colleague Renee Rubalcava. We're both engineers who work on the ArcGIS API for JavaScript, and we're very excited to be talking to you today about the fundamentals of the JavaScript API and the programming patterns that appear throughout the API. We're going to take an introductory approach to the API with a focus on the design of the API and its programming constructs. So rather than focus on a specific part or a specific capability of the JavaScript API, we'll look at its design principles and the programming patterns that appear consistently throughout the API. But first things first, let's make sure we're all on the same page about what makes the ArcGIS JS API so great. We all know that when it comes to choosing a browser-based web mapping framework, you certainly have no shortage of options. And with our recent launch of ArcGIS Platform, it's never been easier to use ArcGIS location and data services with third-party APIs like Mapbox.gl.js and open source APIs like Leaflet. So given that you have more mapping API options than ever before, let's go over the distinct advantages of the ArcGIS JavaScript API. Of course, it provides seamless and robust interfaces to ArcGIS platform services. The two go hand in hand and really allow you to unlock the full potential and the full capabilities of the data and location services on ArcGIS platform. Another really cool thing about the JS API are its client-side analysis capabilities. This allows you to do certain data analysis and spatial operations on the client side without connecting to a service at all. This can be valuable in a number of different use cases, especially if network latency is important to your application, and also if minimizing cost is important to your project, to your application, because, well, there are no data service fees. Regardless of how you perform your analysis, though, the JS API has rich and interactive data visualization capabilities, and they're all powered by WebGL, which, if you're not familiar with WebGL, it's a web technology that allows browser-based applications to leverage the processing power of a device's GPU. Another really cool thing about the JS API is that you have 2D and 3D mapping capabilities in one API. And finally, another advantage of the JS API, and one that we'll talk about in greater detail later in this session, are widgets, which help you build a really professional and well-tested user interface without having to do a lot of the nitty-gritty styling and layout yourself. It really speeds up a lot of the process of developing your user interface and allows you to focus on the logic and capabilities of your application. So now that we know the very powerful capabilities and benefits that the ArcGIS JS API has to offer, I'll pass you guys over to Renee, and he'll get us started talking about some of the fundamental components of the API and the programming patterns.
Hey, thanks, Tristan. So I want to talk a bit about maps and views and the difference between the two. So in the JavaScript API, maps and scenes can be considered to be data models of the API. So they contain information related to the extent of the map or the default extent defined for the map, information about the spatial reference. They also contain information for the base maps and any other operational layers that might be part of the map. But they don't actually draw anything. In order to draw that data, you need to pass them to a view, either a map view or scene view, and it's the job of the views to pull all the data from the map, load all the layers of the map, and then figure out how to display them. We also have some convenient strings you can use when you're working with maps. We have strings for the base maps, what we call named base maps. For example, we have streets, satellite, all the way to the vector base maps that you can use. For the ground, we have a default world elevation layer that's going to be provided by Esri. If you have your own elevation layer, you can also provide it here. In this example here, what I'm doing is I'm going to create my custom base map. So the base layers will be a tile layer, which can be a raster layer. And that is going to be data that's always drawn at the bottom. If I want layers on top of that for reference layers, this could be something like parcel data, maybe streets, or other information that doesn't change very often can be part of my reference layers. So I could create another tile layer here. And then for the ground, if I have my own custom elevation layer that I want to provide, I can use that as well. Let's take a look at this example here. So what I have is I'm going to create my own map. I have a custom base map where I have a tile layer for topographic hillshade, and then I have a vector tile layer for all the streets and other information. And when I combine the two, I have a very nice looking custom base map. That's pretty much what you get with the topo base map that's provided by the JavaScript API. And if I did not provide this map to the map view, of course, nothing would display. So collections in the API are array-like containers that you can use. They're iterable. They have a lot of the same methods as well, but they have a little bit more sugar to them that you can take advantage of. So for example, I have an array of item IDs. These are web map item IDs. What I'm going to do is I'm going to create a collection of type web map and call it web map collection. This means that when I create this web map collection, any item that I add to it is going to be cast as a web map. So it's essentially going to call new web map and pass whatever the item is to it. So I'll take my IDs, I'm going to convert them to an object that looks like a portal item, and then add them to my map. And once I load that map, I'm just going to go ahead and display information about them directly on the page. So if I run this, you see here are the item IDs up here at the top, and then this is the title for each web map that is in my application. So you can use collections to do some really nice things like create collections of various types, and that way you can just add raw data to them and then get those types when you access them from the collection. So accessors are core to the JavaScript API. We use them everywhere. They're used for, of course, reading and setting data. You can define them as read-only. This allows us to do things like have single argument constructors. And one of the most important things is the fact that they provide watchable properties. In this example here, I can treat my accessor object like anything else. I set the opacity, I can set a title. But if I want to set them both at the same time, I can use a set method. I pass it the object with those properties to set multiple properties at once. I can also access deep properties. So essentially, if the map is null, then base map and title be null. But if I do view.get, pass it a string for those properties, it doesn't matter if one of them is null or not. It'll just return null if one of them is null, and if not, then I get back my value. The same goes for setting the property. So I go and set the title to something new of the base map. That's part of my map. That's part of the view. Accessor also allows for property watching. So for example, on the map view, if I want to watch for every time the scale changes, I can do that. And what I'm going to get back is going to be the new value, the old value, the property that I'm watching, which would be scale, and I'll get back the target, which is going to be the view. I can also do it for nested properties, so I can watch for the base map title to change and pass it that string from the map view. So this is like saying map view .map .basemap .title. I can also watch for multiple properties to change at the same time. And every time one of them changes, this function will go ahead and fire. Now, if I do something like this, it's up to me as the user to figure out which property it was that changed. And I can do that by looking at the property that's passed back in the function to decide what it is I want to do. We also have a helper module called watchUtils, which has functions such as when true, when false, and so on, so we can watch for very specific things to happen. For example, on the view, there is a property called stationary that's Boolean, so it's either true or false. If I want to watch for when that property is true, I can use the when true helper of watchUtils to monitor when that happens. So autocasting is a very interesting thing that you can do with the JavaScript API. In this example here, I have an object that's going to represent a marker symbol. And specifically, it's a type simple marker. I could give it a style, color, size, provide another object for the outline, and also have a color and a width. Notice I can pass color as a string like red, or RGBA values, hex values, and so on. And under the hood, we're going to go ahead and convert this to a simple marker symbol. We're going to convert this to a color module that we have. So it's going to instantiate a new color. It'll also instantiate a new outline, which is going to be a different class in the API. Promises. The JavaScript API takes extensive use of promises. It's pretty core to just about everything that happens in the API. So all asynchronous methods are going to return a native promise. When you do something like layer.queryFeatures, you're going to get back a promise. They go and handle that result. And if anywhere inside the promise there's an error, you can catch it and then handle that error. Now, because everything is based off of native promises, you can take advantage of something like async await, which lets you treat your asynchronous code synchronously. So you have to run it inside of an async method. So what I'm going to do is I'm going to wait for the query features results to arrive, or for this to finish. And when it's done, I can start doing something with it. Any code under an await will not run until this is done, so it's complete. So if you have code under here that doesn't need to wait for this, you should probably run it before you start to wait for this asynchronous promise to return. Dynamic imports. This is something you can do with the JavaScript API, especially using the ESM deployment of the API under ArcGIS Core. You can go ahead and you can do a dynamic import for this particular module. And what you're going to get back is an object that's going to have a default property on it. So you're going to want to rename that to whatever it is you want to use. In my case, webmap. And then what I'm going to do is I'm going to go ahead and create a new webmap based on a ID that was passed to this function. This is very useful if in your application you don't need to load parts of the API right away. If you can defer loading parts of your API, I suggest that you do so for performance reasons. However, you should be careful in building your applications because in build tools like Webpack, every dynamic import is going to create its own bundle file. So you don't want to have too many bundles created. You might want to have a single module that loads numerous parts of the API that you can defer, and then have parts or functions of that module that do some of the business logic for you. Continue with promises. Promises make it possible for us to load resources in the API. And they can be do things like load layers and web maps, the web scenes, and the views asynchronously. So when I create a new map, nothing is going to happen to that map. It's just going to sit there and no network traffic is going to occur because I'm not requesting any information. It's not until I give that map to a view that data is going to start to get fetched. Now, once all that data has been fetched and the different layers are being prepared to draw, that is when the view is going to be ready to work with. And this function called when will be called. This is a promise so you can then start doing stuff with the view after it's run. So in this case here, I can do something like, say, run view.when, and then I can ask the view to return a layer view for a layer on my map. When that layer view is ready, I can then go ahead and use the watchUtils helper when false once to watch for the updating property of the layer view to be false one time. And because it only happens once, it's going to return a resolved promise. I'm going to take my result, I'm going to pull the layer view off that result, which would be the target, if you remember from when we talked about how to watch for properties earlier, and then go ahead and query some features on that layer view. This is also a promise. And when those results come back, I can then do something with those features. if at any point in chaining my promises here, something goes wrong, I can go ahead and catch the error and do something with it here. Async await. So returning to async await, we can rewrite that previous function using the async await pattern. I can await for view.when, and then I can create a layer view by awaiting for when the layer view is going to be ready, and then I can await for when the layer view updating property is going to be false one time, and then I get my features by waiting for the layer view query features to run. When that's complete, I can then do something with those features. I can then wrap this async init method inside a try catch, and if something goes wrong in here, I'm going to catch that error and do something with it. Patterns. There are various patterns you can use with the JavaScript API. And one of the most popular things you can do is to watch for different events of the view to create some sort of interactive application. We have an entire list of events provided in the documentation that you can look at for the view that you can use, ranging from click and pointer events to drag events. Now, if you want to stop an event from bubbling up, you can go ahead and run event.stopPropagation of that event, and then something like when the view drag event happens, the user won't be able to drag because you're preventing that from happening. You could do something like view on click is going to return the XY coordinates for the screen. And on screens, that's going to start at the upper left-hand corner at 0, 0 and work its way down. So you take the screen coordinate, you run view.hitTest with that screen point. It's going to convert it to a map point, and it's going to return graphics from the layers that are part of your map that that point sits on top of. Then you can use those graphics to do something. You can use them to do queries. You can use them to highlight features on the map. It's really up to you. Go-to with view. So there's a method on view called go-to. It's a way that you can animate navigation inside your applications. And you can navigate to a geometry, a feature, or a specific location, depending on what you pass to it. Loadables. Loadables are, I might have an application where I'm interested in getting data from my map, but I don't want to display that map on the page. I might want to pull data from the map and display it in a table or charts. So I can go ahead and create a web map, and at this point, we haven't loaded the web map, so no data has been requested. Once I load that map, when it's complete, I can then find a particular layer of the map and then load that layer. Once I've loaded that layer, I can now go ahead and query features from that layer based on a specific query. I can then take my results and then do something with those results. Zoom or scale. So when you're working with the map view or the scene view, most of the time you're probably just going to set a zoom level. But what does zoom really mean? A zoom is based on the level of detail of the base map you're using for your map. And those level of details are predefined based on how the base map was created. So not all level of details are created equal. For example, the level of details between raster-based maps and vector-based maps are slightly different. And that's because of the size of the tiles that are cooked. So what's more reliable is setting the scale of your map. This way your application will be specific whether or not you change to use raster-based maps or vector-based maps. Because scale is portable, scale has meaning. And even if you define a scale, we're still going to snap to the closest level of detail. So this just makes it more consistent across your applications. Sublayer to feature layer. So when you create a map image layer, you're going to have a series of sublayers that are going to be part of that map image layer. Now, sometimes you might want to create a feature layer from that sublayer, which is something that you can do. This way you can use capabilities not normally available with a sublayer. So for example, we have smart mapping tools that rely on having a feature layer to be able to create renderers for your data. So what I can do is I can have a map image layer, load it. I will go ahead and pull a sublayer from that map image layer. I'll create a feature layer from it. I'll pass that feature layer to parameters that I'm going to use for my smart mapping tools. And I'm going to go ahead and create a new renderer with that feature layer in my parameters. And I'm going to use the result of that renderer and apply it to the actual sublayer. So I never actually display the feature layer that I created. I'm just using it to use for the smart mapping tools to create a renderer. And it's going to apply that to the source map image layer. So let's see what that looks like. So here's the default map image layer. I've gone ahead and created a renderer that I can then apply to it using the feature layer that I was able to create from it. Create query. So this is a very handy utility function on the layers you can use to create query objects you can use for querying the layers. The query object that you're going to get back is going to have the layer's filters and layer definitions. It's much more consistent than trying to create a new query and reapply any filters and layer definitions. This way, everything's set up for you. Now, if you don't want any of those predefined filters, you could still create a new query, apply the geometry or the where clause, and then do your query features with that new query. So this is how you might want to use to create query. I've got two feature layers in here. And what I want to do is when that layer is ready, I'm going to go ahead and create a query from that layer and then query features from it. And I'll go ahead and do something to go ahead and work with those results. So if we run this, we can see how this might work. Maybe I'll change the buffer distance, or my earthquakes, and there's my results. This saves me from having to go ahead and create a new query and manually set it up with all the information I need to perform my query. So the map image layer. With map image layers, if you want to modify the sublayers in any way, you should probably do it after you load the layer. Because if you define sublayers for the map image layer up front inside the constructor, it's going to overwrite the defaults, meaning that only the sublayers you provide in the constructor are going to be displayed, which may not be the case. You might want 10 sublayers to be displayed in your map image layer, but only apply a pop-up to one of them, which is what I'm going to do in this sample here. I'm going to go ahead and load my layer before I pass it to the map view. I'm going to find my sublayer, and on that sublayer, I'm going to apply a pop-up template. Once I've done that, I'll give it to the layer, and then I'll pass that to the map view. Now, if I run this application, you see I've got my map image layer here, and I can go and click on the map, and I have the pop-up defined in my pop-up template earlier. Layer views. So layer views are part of the views, the map view and the scene view. So when a map view loads a map and it starts to load all of its data, it's going to take the layers from the map and then create layer views for each layer. It's going to be the layer views that are responsible for actually drawing the data from the layer. Now, one thing that can be tricky sometimes is figuring out when that layer view is done doing its job. So when can you actually begin using it? What you want to be able to do is when you get the layer view, the key to remember is that you want to wait for the layer view's updating property to be false. And if you only want to do something with that layer view the first time around, you can wait for when false once, and then you can query for the extent of the layer view and then go to that extent. This is real handy when you first start an application and your map loads, and you may not know what the full extent of the layer is going to be up front. So you can let the application go ahead and take care of that for you.
Thanks, Renee. So now we know that layer views are responsible for visualizing the data in a layer. But how do we specify how exactly we want that data to be visualized? Specifically with vector datasets or feature datasets, we usually have, in addition to the geometries, some sort of attribute data. And oftentimes we want to visualize our data in a way that shows not just the location in space, but also communicates some of the information in that attribute data. And that's where renderers come in. Renderers allow us to specify exactly how we want to visualize our data and what information we want to communicate through the visualization. Basically, to build our renderer, we start with the question, what story do we want to tell with this layer's data? This might all be sounding a little abstract, but some examples will make it clear. So here we see different methods of visualizing data and the renderer classes that we can use to accomplish that type of visualization. I won't explain all of these renderer types here because we're going to see a demo with a few of them in just a minute, but I just wanted to show the range of visualization methods available and the many renderer classes that you can use to achieve those types of visualizations. But without further ado, let's take a look at a demo. So here I've set up a map in a map view, and I've added a feature layer that has 2016 presidential election results for the state of California by county. And as you can see in the view right here, right now we're just using the default renderer. It's a simple renderer. It shows only the location of the county boundaries in California. We can do a little bit better with this data layer since it has election results in it somewhere. Let's pull those out through the visualization. So to do that, first let's try a unique value renderer. So you can see we're going to calculate an expression, a Boolean expression, that will be true if Hillary Clinton won and false if Donald Trump won. And then for each of those values, true and false, we assign a symbol. To the value true, we assign a simple fill symbol with a color blue, blue for Democrats. To the value false, we assign a simple fill symbol filled with red, red for Republicans. So let's see what happens when I set the renderer property on our feature layer to be this unique value renderer. Okay, so now we have a bit more insight into how the election results panned out in the state of California in 2016. As you can see, counties where Donald Trump got more votes are red, and those where Hillary Clinton got more votes are blue. But notice that as we look at this, we see a lot more red than we do blue. And if you're familiar with the state of California and its politics, you know that they tend to be very blue. And that suggests that maybe there's a way that we could render this data that would communicate the election results a bit more clearly or intuitively. So to do that, let's try a class breaks renderer. With a class breaks renderer, you choose a value. Oftentimes it's the value of a field, but in this case, we're going to use another expression. And you take the range of possible values for that value, and you subdivide it into smaller ranges. And then to each of those ranges, you assign a distinct symbol. So the way that I've formulated this expression, the value is going to be -1 if Trump got 100% of the votes, and it's going to be +1 if Clinton got 100% of the votes. And just as our values range from -1 to +1, I've made these colors also follow a sort of gradient where at -1 we have pure red, at +1 we have pure blue, and then toward the middle we have more evenly mixed colors. So let's see what this renderer looks like. All right, let's take a look at this. So already, this looks a little better. We're less overwhelmed by the red, and we see a little bit more complexity. We see some purple where the distribution of votes was a little bit more even. So this does a better job of communicating the election results in an intuitive way. But still what's missing from this map is some indication of the relative importance of each county. And what I mean by importance is the number of registered voters. In this map, a pure blue county is better for Hillary Clinton than a purple county, and a purple county is better than a pure red county. But of course, the real story is a little bit more complicated because a pure red county, where Trump got, say, 80% of the vote, would be a lot less concerning to Hillary Clinton's team if there were 50 registered voters in that county than if there were 5,000, because in winning the state's electoral votes, all that matters is the total popular vote throughout the state. So let's try to communicate that additional dimension, that relative importance of each county, through our renderer. So this time we're going to try a dot density renderer. And as you can probably tell by the relative brevity of the code here, this renderer was actually the easiest to configure. And in my opinion, it looks the coolest and does the best job of conveying the election results. So let's get this renderer on the map, and I'll explain how it works. So with the dot density renderer, we choose attributes and we assign them each a color. So in this case, I have the field that represents the number of votes that Clinton got, and I've assigned that blue, and the field that represents the number of votes that Trump got, and I've assigned that red. So to get a sense for how this renderer works, let's select a precinct here. And so for this precinct and for the polygon geometry that represents it, the dot density renderer is going to look at the value for this attribute that we've selected, the number of votes that Clinton got. In this case, it's 784. So it's going to draw 784 blue dots inside of this polygon. And then it's going to look at the value for the number of votes that Trump got, 308, and it's going to draw 308 red dots. And so when we zoom out and look at the big picture here, we see that the dot density renderer manages to communicate three distinct things from our data set. For any given area, we can look at it and tell roughly whether Hillary Clinton or Donald Trump got more votes in that area, how big was the margin, and how many voters are there in that area, and therefore how important is it for the candidate that won that they got those votes. And so as we've seen here, the ability to configure renderers for our data sets gives us great power to determine exactly what information in our data we want to communicate, and to do so through the visualizations of that data. The last fundamental component of the JS API that we'll talk about today is widgets. Building a UI for a web app is an extremely complicated task, and it's one where you can spend a lot of development time and effort on small things that ultimately don't add a whole lot to the overall experience of using your application. The widgets in the JS API offload a lot of that complexity and make building your UI more of a task of configuration as opposed to building things from the ground up. They result in a UI that is responsive, accessible, and localized by default without any additional work or input on your part. The API comes with over 40 widgets out of the box, and they're built on a very simple and easy to use component structure that you can use to extend or build your own custom widgets. And the great thing about the widgets in the JS API is that they're built specifically for maps-based applications. So of course, UI kits for web apps are a dime a dozen. There are a ton out there. But the widgets in the JS API are developed specifically for maps-based geospatial applications. Let's take a look at a few widgets, and I think you'll get a sense for just how easy it is to get up and running with some really cool user interface components. So to start, again, I have a map and a map view, and I've added a feature layer. This time, we're going to my homeland, Oakland County, Michigan, and we have a feature layer from the county government that shows all of the sledding locations in Oakland County. The first widget I've added here is a scale bar. That's this thing down here that shows the scale of the map, and as you see, as I zoom in and out, it adjusts to match the scale of the map. And it's very easy to add. All I had to do was pass our map view, specify what units I wanted. In this case, I chose both because I presume we have users of both the metric and imperial system online today. And a position, I've chosen the bottom left of the map view. And I just passed all of this as an argument to the view.ui.add method, and here it is. The next widget I added is the base map gallery, which allows us to select any base map for our map view. And in this case, I've found that it's best to look at the sledding locations with some imagery so we can see some of the details. You may have noticed the base map gallery right now is taking up a lot of real estate in our user interface, and it's not necessarily something that we're going to be using all the time throughout our use of this application. So what we can do is we can put it inside of another widget called the expand widget, and I'll show you what that does. So I'm going to take out this line where I add the base map gallery directly to the view, and instead I'll bring in this line where we have an expand widget, and I've passed the base map gallery to the expand widget as its content. So now we see that the base map gallery is inside of this expandable, collapsible panel, which is nice because we can easily access it when we need it, but it's out of our way when we don't. The next widget I added is bookmarks. Bookmarks allows you to save places on the map for easy navigation back and forth between them. So I've created one for us called Shiawassee Hill, and this has the location of the Shiawassee Hill sledding location, which is, in my completely unbiased opinion, the best sledding location in all of Oakland County and the one that I went to as a child. And I'm going to use the last two widgets I added to our map here to explain to you what makes the Shiawassee Hill such a great sledding location. So first we have the sketch widget here. And the sketch widget is good for annotating maps or making temporary drawings if you want to make annotations while you're presenting a map to someone. So as you can see, first I use the polyline tool. This is the polygon tool. I'll add another polyline here. And then the other widget that I added is the elevation profile widget. This allows us to draw a polyline over our map. And as you'll see in the graph there, it shows us the elevation of the path that we're drawing. Okay, so as promised, the definitive case for why Shiawassee Hill is the greatest sledding location in all of Oakland County is that every year the county comes out and lays hay bales down along this path to make it easier for sledders to trudge uphill. They put up a barrier of hay bales right here to separate sledders from the vulnerable people walking slowly up the hill. They put another set of hay bales right here to prevent sledders from running into the roads. And it's just a great site selection because as our elevation profile shows us, it's a pretty long, nice downhill. And then right at the bottom here, before you get to the road, there's a slight uphill to slow people down before they crash into the hay bales or worse, run into the road. One more particularly fundamental, important widget that I wanted to be sure to show you all is the pop-up widget. Pop-ups are an essential part of any web mapping application. They allow users to click on features and to see all of the attribute data attached to that feature. Now, conveniently in the JS API, every map view has by default an instance of the pop-up widget on it already, and you can enable it by setting this property default pop-up template enabled to true. So without any more work or configuration, you can have pop-ups up and running in your application. Now, one of the shortcomings of using a default pop-up is that the way that data comes out of the database is not always or even often the best way to show it to users. So for example, if I was a user who was not familiar with the conventions of database field naming, labels like PONAME, POP 2018, SQUAMI might not mean much to me. We could probably have more intelligible labels for those fields. Another thing is we have the sum of total vehicles and the sum of electric vehicles here shown to 2 decimal places. It's probably unnecessary as we're probably not concerned with fractional cars. So you get the point. We often want to be able to format our data after we get it out of the database before we show it to our users. So I have one more demo here, and I'll show you how you can customize pop-ups in order to format the data in a way that looks good to users. Here we see the default pop-up for this Oakland County sledding locations feature layer. And over here, I've created my own pop-up template. I've said that I want the title of the pop-up to be just the name of the sledding site. I want to include the address field, the city field, the phone field, just how they are. They're good. I want to include this agency field, but I'd like to label it operator instead of agency. And same here, I'd like to include this rec center field, but I'll label it facility. And then the other thing I've done down here is instead of including this website field as a field in the attribute table, I've included it as an action. So I have a button that says more info that goes to the link instead of just displaying it here in the table. So I will uncomment this, and you'll see here I'm setting the pop-up template on this Oakland County sledding feature layer. And now if we click on one of these features, we see our custom pop-up with no all capital field labels, exactly the fields that we chose, and our more info button right here. As I mentioned earlier, in addition to the out-of-the-box widgets that come with the JS API, you're also able to build your own widgets. So for that, it's helpful to understand how they're structured. Widgets have two main components. The first is the view, and the view is responsible for rendering the user interface and listening for user input events. And the second component is the view model. And the view model manages the data structures and the internal business logic for the widget. There are many different ways to customize the widgets. The most basic is to give them your own styling. Our widgets are styled with Sass, which, if you're unfamiliar, is like CSS on steroids. It has some really cool features that make styling easier to do and to work with. And you can use the Sass variables and selectors that our widgets use to hook in your own styling to the widgets. Another great option for customizing the widgets that goes further than just adjusting the styles, but is less of an undertaking than developing a widget completely from scratch, is to take the view model class of a built-in widget and write your own view class. This is great for a use case in which one of the built-in widgets has most of the business logic and functionality that you need, but you just need a little bit more flexibility in terms of being able to determine the user interface of it. So you can write your own user interface by writing a view class. And finally, if you'd like, you can start from scratch and build your own widget, write both the view model and the view, and there is plenty of documentation and tutorials on how to do that. And speaking of documentation and tutorials, for those of you who are new to the JS API, I wanted to point out all of the resources that we have to help you learn the API and get up and running with it. We have nearly 300 code samples on our developer website. They're a great resource to turn to if you just need to figure out how to do a specific thing. And you can also study them as examples to see the patterns that we've learned about today applied. We also have a couple of open source starter apps. These are great if you want to skip over all the boilerplate work of bootstrapping an application from scratch and get right to developing the actual application. You can just clone the repositories for these apps, set them up on your development environment, and get going. And finally, we have a number of ways to use the JS API to build apps without actually having to write a ton of code or even any code at all. There are some really cool tools here. I've linked to them all here, and I encourage you to check those out. Thank you very much for joining me and Renee today. Please, if you have a moment, fill out the feedback form that's linked below, and I hope you all enjoy the rest of Dev Summit 2021. Thank you.
Hi there. Thank you for watching the session today. So we're going to go ahead and cover some of the questions that have come up in this session. So Let me get to the very top of our questions here. I did provide a link for the slides in response to, will you be providing the links to your CodePen stuff? So it looks like the generated PDFs don't have links directly to the CodePen samples. So they are in the GitHub repo that I replied to in the reply to that particular question. So you can go ahead and view the actual slides there, and that has all of the links. Let's come down here a little bit more. Is the ArcGIS API for JavaScript used in Experience Builder? Yes, it is. So what's really neat with the Experience Builder is that it uses the 4x version of the JavaScript API from scratch, completely built out. So if you want to build widgets with the Experience Builder for custom development, you would be using the 4x version of the JavaScript API. And this isn't necessarily an Experience Builder session, but I can tell you that the Experience Builder widgets do use React as the framework to build them on. So you have to have a little bit of React knowledge, enough to build UI and everything and get those done. So that'll help out with that. But yeah, it is 4x. So to answer that particular question. Can we update bookmark widgets extents dynamically? Not sure I fully understand the question. It sounds like you want to edit the bookmarks that are part of the widget or might be saved in the web map. Yes, you can. The bookmark widget has a way to manage the bookmarks and everything and adjust them. If you need to, you could delete them, add new ones, and so on and so forth. So yes, that is something you can do. Tristan, you want to cover this next question here on the preset class breaks?
Yes. Let's see. So can you invoke preset class breaks like Jenks or something similar? Yeah, so in the demo that I showed with the class breaks renderer, I made my own, I set my own class breaks, but you know, for a lot of applications, you won't need to go into the nitty gritty of doing that. And so you can use preset class breaks. And for that, we have, I think I posted a link to the doc for the create class breaks renderer utility or factory method. And that lets you set a whole bunch of configuration parameters for your class breaks renderer. And one of those parameters is called, what's it called? Sorry, everyone. Is called classification method. And so we have 4 accepted values for that: equal interval, natural breaks, quantile, and standard deviation. And someone asked about Jenks in particular, and natural breaks is how you would get that. So I think like I said, I think in the response to this question, I posted a link to the doc for that factory method. So you can go there and check out not only the available classification methods, but also a bunch of other configuration parameters for making a class breaks renderer.
Awesome, thanks, Tristan. Okay, so there was a question here that I approved for. Is it possible to implement the time slider widget with multi-patch features in the scene? I actually misread the question when I first approved this. So I don't necessarily know if it works with the multi-patch features, but I do recommend that you go to the Ask the Experts section, and I'll put a link in here for you for that. Someone there would be much better suited to answer the question on 3D related stuff. I'm not necessarily well versed in the details of working with 3D data, so you're better off asking that question there. Sorry about that. I wish I did have a good answer for that, but unfortunately I don't. How do dynamic imports work with the Webpack build? So when you're working with Webpack and pretty much any modern build tooling like Rollup and stuff like that, what the dynamic imports are going to do is actually going to create a bundle file for the file that you're importing. And that bundle file will also have all of the child assets for that file. So any other JavaScript that might be imported in there is also going to be part of that bundle. And if part of that bundle includes any dynamic imports, it creates more chunks and so on and so forth. So they're really useful to lazy load code in your applications when you're building your app. Like maybe you have a part of your application that doesn't need 3D until someone does something. So you don't want to load all the 3D files up front. You just want them when they actually need them. That's very useful there. It is, but one thing to keep in mind though is that if you do that a lot, dynamic imports, it creates much more JavaScript files, right? And there could be some overlap between one bundle and another bundle. So you're actually loading more code than might be necessary. So I recommend you don't necessarily get carried away with dynamic imports, but they can be very useful in certain situations, especially if you're going to load UI components that might need some mapping libraries, but they're not going to be loaded up front, right? So that's where you really want to take advantage of dynamic imports in Webpack or Rollup, or pretty much any other modern build tool will act the same way. So I hope that answers that particular question. Where can I find the view model code? The TSX for the editor widget is available, but I can't find the TS file for the editor view model. So we don't provide the source TypeScript for the view models. The only things that we provide are the TSX files. So all of the widget view code is available. We don't provide the source for the view models. And we do that because the implementations for the view models to handle all the business logic and everything for the widgets are not open sourced, but the views, you can use them and they give you an idea of how you can take advantage of our view models and our business logic to maybe build your own UIs for various parts of your application. So if you want a custom editor widget, you can use the view model and you can look at how in the editor widget code, how we use the view model to do certain things. So that's kind of where that idea came from, to publish the source TSX files for everything. So unfortunately, no, the view model code is not available. Okay, so this question came up. I'm loading two maps in the view. One is the base map streets, the other is third-party provider may not always be available. How can I know if the streets map is the only map loaded in the view? So there is some method to it. I'm going to post a link. I think I did post a link to one of the load error on the layers. So there's a couple of load properties on the layers. There's, I think, loaded, load error, and load status. You'd want to check the those properties to see if there was an issue loading that particular layer. That's how you can check to see if there was an issue loading the map, because the web map or any map is not going to get rejected. So if you do like a map.load or webmap.load, we're not going to reject the map just because one layer didn't load. So you need to go and look at the individual layers to see if there was an issue loading any of them. We don't necessarily want your map to fail just because one layer failed to load. That would be kind of a pain to deal with in development and production if that kind of happened. All right, so that's what you want to do. If I'm connecting to PKI-enabled WNS endpoint, is there an easy way to do authentication server-side via proxy to avoid CORS errors in the JavaScript connections?
I can take this one, Renee.
Awesome.
We recently added on ArcGIS service layers, we recently added custom parameters property. And so you can set that property custom parameters to an object with API gateway keys that you might need. So, without knowing the details of this specific setup, I'm not sure that would satisfy your use case, but that's one thing that custom parameters property is one thing that a lot of people with proxy servers or API gateway setups use to get their service credentials in their layers. And then another question, can I split the window with two maps side by side, for example, a street level view and a detailed utility network view having interactions between the two maps? For that, there's a widget called Swipe. You can check that out in the API docs, but Swipe allows you to have basically two layers that are the top layer of your map, and you can swipe between them to show one or show the other. That's really good for making comparisons, like between time dynamic information. You can compare between two time frames, or you can compare two layers that are showing sort of the same data but rendered differently, or maybe you have an RGB image in one layer and some multispectral coloring of another in another layer, and you can swipe between them. It's really good for seeing differences and making comparisons.
Very cool. So there's a question here. Are there ES module examples or templates available? There are. Let me get a GitHub link for you here. We have a repo on GitHub. And because it looks like, sorry about this, it looks like the links get removed when I mark a question as answered. I didn't realize I was going to do that, and I removed a few links. I am putting them back in as questions, these particular links. So I just posted the link below to our GitHub repo, JS API resources. We have a folder in there called ESM samples, and we have multiple samples using different build tools, React, Angular, Ember, Node.js on how to use the ESM build in those particular environments. So that would be a great place for you to get started looking into that if you want to start moving away from AMD and start building with ESM. I have a session on ESM, building apps with ESM. I think it's tomorrow. And we have a session this afternoon for options for consuming the API that you can also view later today. Some new build tools other than Webpack and Rollup are things like Vite.js and Snowpack, which have very little configuration needed because they are ESM first build tools. So if you want to use those, I highly recommend them because there's much less overhead than using something like Webpack or Rollup, which aren't necessarily, well, I guess Rollup is built for ESM, but like Webpack wasn't necessarily built with ESM in mind when it first came out, even though it supports it. If you've seen a Webpack config, it can get pretty unwieldy once you start doing a lot of things with it. I just happen to think that Snowpack and Vite are much easier build tools to use today. So you might want to check those out. Let me see here. Will the online documentation for scripting and JS API be updated to use React.js? So the SDK, our online doc that we have on developers.arcgis.com, that's not going to be updated to use any particular framework. We're pretty framework agnostic. But the link I just posted in the questions that goes to the JS API resources, that does have a React sample in there along with a bunch of other ones. So we're not recommending that you use any framework. We're not, that's not our job to tell you what frameworks to use. Our job is to provide the API in a way that you can use it however you want to use it. So it pretty much works across the board everywhere now. And I also want to point out that it used to be that you would need to use our Webpack plugin just to get to work with Webpack. You don't have to do that anymore at all. The Webpack plugin is completely optional, only if you want to copy local assets. And again, I'll cover that in more detail in other sessions, but you don't really need to do any of that anymore. It should just work in pretty much any environment now. So I think we have time for like maybe one more question here. Tristan, did you want to pick a question out, or I think we might be good if not?
Wow, there are so many good questions. I don't think I can pick in the time we have left, but I would like to say, oh, okay, go ahead.
Sorry, here's one I think we can cover real quick. When's the release date for 4.19? 4.19 should be out, I think it's 2 weeks. It'll be out this month because online should release next week, and then the API releases 1 week after the online release. So keep an eye out for that.
Okay. There is one question I have to address, which is why is my house so clean and why doesn't it have furniture? I just moved in. I just moved here, guys. So, or people. So sorry about that, but maybe next year. Hopefully we'll be in person again, though. We have so many questions that we didn't get a chance to address, and to those questions and to the people asking them, I'd like to say, be sure to join us in the Ask Our Experts section of the virtual conference, and specifically, we'll be in the what's it called, the web development channel of the Ask Our Experts. I personally will be there from 2 to 4 this afternoon, 2 to 4 Pacific. But the whole conference, there will be people from the JS API team there to answer your questions, and we'd love to talk to you.